Just like when graphing sine and cosine, the first thing I'm going to do to figure out the graph of tan is to fill out my unit circle. So I'm just going to let it go and get the unit circle filled out quickly. What we'll need to remember is how to find tan from a unit circle. So remember, tan is always the y value divided by the x value. So remember, the y values all the way around the unit circle are sine, the x values all the way around the unit circle are cos, so this is actually, tan is actually sine theta over cosine theta. Now I'm just going to start filling in the table of values by moving around the unit circle and dividing the y values by the x values. So 0 divided by 1 is just 0. 1/2 divided by root 3 over 2 is 1 over root 3. Just forget about the denominators because they'll cancel. Root 3 over 1 is root 3. 1 over 0 is not defined. And we'll deal with the undefined and talk about it in a minute. But let's just keep on moving around the circle. Root 3 over negative 1 is negative root 3. 1 over negative root 3 is negative 1 over root 3. 0 divided by negative 1 is just 0. And just keep on going around the unit circle. At 3 pi over 2, again, we get negative 1 divided by 0. So anytime we divide by 0, it's not defined. And what's going to happen with these undefined is that those are where vertical asymptotes are. Okay, they're basically, it's like the reciprocal. When we were going 1 over a 0, that's where an asymptote occurred. It's the same thing here. It's 1 over 0 or negative 1 over 0. So I'm just going to highlight those two. So those are where the vertical asymptotes are. It's worth noting the pattern in the asymptotes. So there's a vertical asymptote at pi over 2, 3 pi over 2, and it just keeps on going with any odd numerator over 2. So 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2. It just keeps on going forever. It's also important to remember that just because this stops at 2 pi, that doesn't mean our graph stops at 2 pi. You can just keep on going around the unit circle to find more values if you want. Same thing, we could go to the left of 0, or we can go in a clockwise direction instead and get negative values. So this function, just like sine and cosine, it continues forever. All right, now we can start graphing this. I'm just going to change the root 3's, anything with a root 3 to a decimal, so I know where they are. So 1 over root 3 is 0.58. Root 3 is 1.73, and then we can just imagine that for the negatives. So for my y-axis, I think I'm going to actually do every square going up is 1 unit. And then on the x-axis, it's every 6 is pi. And I'm just going to start plotting them. I plotted the vertical asymptotes in first, which were at pi over 2 and 3 pi over 2. And then I'm just plotting the values. At 0 is 0, at pi over 6, 1 over root 3, which is about 0.58. So I'm just estimating it about halfway, a little more than halfway, 1.73. And it's just plotting those in. And you can see this is the basic shape of tangent. We'll just draw this quickly, but basically it's always in between these two asymptotes. To the left, as you go towards an asymptote, it's always going down. To the right, it's always going up. And they keep going up forever and following the asymptote. Up and down to the left, up to the right, no matter what. And it's always halfway in between the two asymptotes that you have your x-intercept. This is what a cycle of tan looks like. So from pi over 2 to 3 pi over 2, from between those two asymptotes, that is the basic cycle of tan, and its period is pi. So sine and cosine both have a period normally of 2 pi, and that's a big difference for tan, is that it's only got a period of pi.